Sorry, I cut myself off there. There are times that you do want to do parts twice in a row, but when you do it, you want to make sure you're not crossing the streams. The big mistake we made, or the thing that happens every time that you do it, is we made our new U our old V. We made our new dV our old du. Basically, they were off by constants, but the constants don't really matter. Switching directions undoes the parts that you just did and gives you back the original problem. And that is never going to be productive. It's like doing a substitution with u equals x. It's a trap you need to look out for. So, that illustrated a thing that went wrong. Let's go back to the original problem. X squared cosine 5x. I made a note earlier that our first choice of u was not a good one. The last time we picked u to be this thing, and that turned out to be not so good, because when we integrated x squared, it turned into x cubed. We got even more x's, we want even less x's. If I make u the x squared thing, that's good, because the derivative of that will be 2x. We'll have even fewer x's than we had before. dv will be everything else, cosine 5x dx. So what's du? It's derivative of that, dx. What's v? It's the integral of that. What's the integral of cosine 5x? This is one of those baby substitutions. You can do a substitution here if you hate it. If you really do want to do a substitution, you're probably better off doing the substitution u equals 5x on the original problem. I think that's the cleaner way of writing it, but you do you. Oh, that delights me. You do you. Because it's a u substitution. Get it? Yeah. V is the integral of cosine 5x. The integral of cosine is sine. I need to deal with the fact that when I take the derivative, it's going to poop out a 5. I put 1 over 5 to cancel that. I could put plus a constant, but I almost never want to do that. Okay, this is u. This is dv. The integral of u dv equals uv minus the integral of v du. What's uv? It is x squared times 1/5 sine 5x minus the integral of v, 1/5 sine 5x du, 2x dx. This looks pretty gross. I want to rearrange these things to look nicer. That's 1/5 x squared sine 5x minus the 1/5 as a constant can come outside. The 2 as a constant can come outside. I get 2/5 outside. Integral of x sine 5x dx. We just did an example where integrating by parts twice in a row completely was pointless because the second integral by parts undid the first one. Don't let the lesson from that be don't do parts twice in a row. Sometimes you need to do parts twice in a row. The lesson should be when you do parts twice in a row, keep moving in the same forward direction. Don't let your new u be the old v. The old v was the sine 5x part. Don't let u be sine 5x if you do parts again. We do need to do parts again. We have x times it. The thing worth noticing is when we did parts, we changed an x squared integral into an x integral. The cosine turned into a sine. That part we don't care about. Sine and cosine are equal difficulty in our brain. But the x squared turned into an x. We got one less x when we did the parts. If we do parts again, we can get even less x's. Once there's no x's, we know how to do it. It's not even multiplication anymore. So that's the moral of the story. I'm going to let u equal x. There's another trick I'm going to do, which is this 2/5 out front is going to need to be out front of the whole thing, which is gross and sort of adds another step where I multiply the 2/5 in. In my mind, if I need to do parts again, I think it is much nicer if I keep the 2/5 inside the integral. I know I just pulled it out, but I want to put the 2/5 inside there and stick it on as part of the u. That way, it'll be all taken, it'll be baked into the formula and not a thing we have to deal with afterwards. I'm going to let u be the 2/5 x. Oh, actually, I'm also going to put the negative inside, because then I don't need to distribute the negative through either. Now I can just write this plus, write down the integral by parts formula, no parentheses necessary. This is not a big deal, it's a little trick that You pick up a lot of these little tricks as you do enough problems. U is negative 2/5 x, so what's du? Du is derivative of that. Negative 2/5 dx. dv has to be everything else, so dv has to be sine 5x. If dv is sine 5x, what's v? It's the integral of that. What's the integral of sine? It's negative cosine. Leave the inside alone. Divide by that constant. This only works because the derivative is a constant. I could put a plus c, I don't need to. Okay, the integral by parts formula. This first part is still there. 1/5 x squared sine 5x. Plus, now I need u times v. This is negative times negative cancels. I get a positive. 2/5 times 1/5. 2 on top, 25 on bottom. X cosine 5x. Minus the integral of v du is minus the integral of v is negative 1/5 cosine 5x times du is negative 2/5 dx. These are negatives that cancel. I got 3 negatives. I end up with a negative. I got this stuff plus this stuff minus 2/5 times 1/5 is 2/25 integral cosine 5x. And I know how to do that integral. The integral of cosine is sine. Need to divide by 5 out front. Dividing by 5 will make this 2/125. And the other part of the answer was this. 1/5 x squared sine 5x plus 2/25x cosine 5x. I'm going to check my answer by taking the derivative. I used parts. I'm expecting you need a product rule. Sure enough, I do need a product rule. Derivative of the first is 2/5 x. Leave the second part alone. Plus, leave the first part alone. 1/5 x squared times the derivative of the second part is derivative of sine is cosine. Cosine 5x times 5. Plus, to take the derivative of this also needs the product rule. Derivative of the first is 2/25. Leave the second part alone. Cosine 5x. Plus leave the first part alone, 2/25x. Derivative of cosine 5x is negative sine 5x times the derivative of the inside is 5. Minus, what's the derivative of this? 2/125 is a constant out front, stays out front. Derivative of sine is not sine, it's cosine of 5x times the derivative of the inside is 5. Look at this mess. It's supposed to be x squared cosine 5x. Well, that cancels with that. Hey, here's our x squared cosine 5x that's supposed to be the answer. Here's 2/5 x sine 5x. Here's 2, 25 and 5 leaves 5. X sine x, but this one's negative. So this ends up canceling with that. And I'm guessing this should end up canceling with that. This is positive 2/25 cosine 5x. This is negative 2/125 times that 5. We'll leave that as 25 cosine 5x. Everything we didn't want cancels out of the way, leaving us with just the thing we want. And if I stare at the integral by parts, the first integral by parts gave me the thing I want, but also this garbage. The second integral by parts gave me something to cancel that garbage, but some new garbage. The last integral said what will cancel with that new garbage. Like the integral by parts is sort of playing catch up. I can fix this, but I'm going to get that. I can fix this, but I'm going to get that. And yeah, this is integration by parts.